Welcome everyone to the AI Research Roundup. I'm your host Alex, and this is where we dive into some interesting developments in AI research. Today, we're looking at a paper called NdLinear is all you need for representation learning. The main idea is quite neat. It tackles how neural networks often flatten multidimensional data like images or scans, losing structural information. The paper proposes NdLinear, a new linear layer that preserves these structures by operating along each dimension separately. They suggest this captures dependencies that standard layers miss, potentially improving models. So Figure 1 here really highlights this efficiency point. It plots the top 5 accuracy against the number of parameters for vision transformers on the CIFAR 100 dataset. You can see the standard linear layer version, that's the black line, needing quite a few parameters to climb up in accuracy. The blue and cyan lines represent models using NdLinear. Notice how they achieve higher accuracy, while using significantly fewer parameters on the x-axis. It clearly shows that NdLinear seems to be much more parameter efficient. Okay, so building on that idea of efficiency and preserving structure, Figure 2 here gives us a nice visual comparison. Down at the bottom you see the standard approach, taking a multidimensional input like a cube, flattening it completely, and then applying the linear layer. But look at the top path. That's NdLinear. It takes that same cube, but processes each dimension separately, transforming D1 to H1, D2 to H2, and D3 to H3, all while keeping that original cube-like structure. It really shows how it avoids that flattening step we talked about. Okay, so Figure 3 zooms in a bit more on how NdLinear actually handles one of those dimensions we saw in the previous figure. Let's focus on transforming just the first dimension, D1, into H1. You see the initial cube, then it gets temporarily reshaped, kind of flattened, but only partially, so that the specific linear transformation for that dimension, W1, can be applied. After that step, it's reshaped back into that cube form, but now that first dimension has the new size, H1. And remember, this kind of process happens iteratively for each dimension. Okay, so moving on from the mechanics, let's look at how this performs on different kinds of data. Figure 16 here dives into time series classification using 6 different datasets. Similar to what we saw in Figure 1, the bars represent performance, which is F1 score this time, and the lines above show the number of parameters. Across all these varied time series tasks, you can see NdLinear consistently getting a higher F1 score, while again using notably fewer parameters compared to the standard linear approach. It's showing that same pattern of better performance with greater efficiency. So we've seen efficiency in time series. Now Figure 19 brings us back to image classification, but with a focus on how things scale within transformers. This looks at CIFAR 10 and CIFAR 100 again, plotting accuracy as we increase the number of transformer blocks along the bottom. And similar to what we saw earlier in Figure 1, the NdLinear version, that blue line, consistently stays above the standard transformer, the black line, in terms of accuracy on both datasets, even as the models get deeper. It really shows that the performance advantages seem to hold up as you scale the architecture. Okay, so we've seen how NdLinear performs in vision transformers. Now Figure 21 takes us into the realm of large language models, specifically looking at OPT models. Here the metric is perplexity. And remember, lower perplexity means the model is better at predicting the next word. You can see for both OPT small and OPT mid, the NdLinear versions, those blue and cyan bars, achieve a lower perplexity score compared to the standard linear layer. This suggests NdLinear improves language modeling performance too, and the paper notes this also comes with a reduction in parameters. So looking across vision, time series, and now language models, we've seen a pretty consistent story emerge. The NdLinear layer seems to offer a compelling way to get better performance, often with significantly fewer parameters. It really highlights how rethinking even fundamental building blocks like the linear layer can lead to broad improvements across different areas of AI. It's quite exciting stuff. That's all for this episode. Thanks for tuning in to the AI Research Roundup. I'm Alex.